Welcome to Study Loop.
So, because the transformers are assumed to be perfect, the power loss is due to resistive heating in the transmission lines. Now, the town requires 55 megawatt, and we need the transmission efficiency to be 98.5%. Therefore, the power at the generating plant must be 55 megawatt over 0.985, so that is equal to 55.838 megawatt. So let's say this is P1, this is P1, this is P2. Therefore, the power loss will be equal to P2 minus P1, and that is equal to 0.838 megawatts. Now this can be used to determine the current in the two transmission lines. So as we said, the power loss is due to the resistive heating in the transmission lines. Therefore, this loss in power is equal to current in the transmission lines times the equivalent resistance of both the transmission lines. So this means that I will be equal to square root of power loss over the equivalent resistance. So now we substitute the values, making sure that our units are consistent, and the equivalent resistance is twice of the resistance of each transmission line. So that is given to be 0.10 omega per kilometer, and that each transmission line is 56 kilometers. So we multiply that to get the resistance in each transmission line, and then multiplying it by 2 gives us the equivalent resistance of both the transmission lines. So we calculate that and find the current to be 273.6 ampere. Now to produce a power of 58.838 megawatt at this current 273.6, the following voltage should be required. So power is equal to current times voltage. So the voltage required will be equal to power over current, and this is going to be P2. Now we substitute the values for P2 and I that we calculated and find voltage to be 2.401 times 10 to the power 5 volts, and this is nearly equal to 200 kilovoltage. So that's the voltage required. Thank you.